In this and in coming videos, we will see how to actually compute margins of error E in different scenarios. In the introductory confidence interval videos, we talked about examples like the mean age of Brookdale students or the mean age at which some men develop prostate cancer. Those confidence intervals were all centered about the sample mean X bar. So we were using the sample mean X bar as a point estimate of the population mean mu. We are going to switch gears here in this particular video and not focus on the population mean. Instead, we're going to focus on something called the population proportion. We're going to construct a confidence interval for the population proportion. So let's first look at this example that's going to guide the way. In a survey of 938 US adults, 235 say the phrase, "you know," is the most annoying conversational phrase. Construct a 99% confidence interval for the population proportion P of US adults who think the phrase, "you know," is the most annoying conversational phrase. Interpret your results. So ultimately, by the end of this video, we want to fully answer this question here. Notice there's no mention of a mean anywhere in this example. Instead, what we want to know is what percentage of US adults find the phrase "you know" to be the most annoying conversational phrase. So we're not looking for a mean mu. Instead, we're looking for a population proportion, or just said differently, a percentage of US adults who think the phrase "you know" is the most annoying conversational phrase. So instead of using mu, because it's not a mean, we're looking for the population proportion or the population percentage. I prefer to say percentage myself. And that is defined as the lowercase letter p. That is our population percentage. So we want to know what percent of US adults think that "you know" is the most annoying conversational phrase. Now, of course, we can't interview all US adults. So what they did is they took a survey of 938 US adults. So we don't know P, but we want to come up with a confidence interval at 99% confidence that that will house the actual population proportion P. So we need an estimate for that P. That estimate is what we call P hat, and that's read as P hat. P hat is going to be an estimate for P. A point, specifically a point estimate. It's not an interval, it's a specific point. We will talk about how to compute P hat on the next slide. But just to give you a larger picture here, again, we're talking about population proportion, not means. And so we are going to use this population proportion estimate, P hat, as the center of our interval. Then we will compute a margin of error for which we can add that margin of error to P hat to get the right-hand side of the confidence interval, and we can subtract E from P hat to get the left-hand side of that confidence interval. But first, how do we compute P hat? As you can see here, P hat is equal to X divided by N. So we need to know what this X and this N represents. And technically, you've seen this before. People either think "you know" is the most annoying conversational phrase, or they do not feel it's the most annoying conversational phrase. So this is binomial in nature. And recall, when we studied discrete probability distributions, we looked specifically at the binomial distribution. So this problem here is built directly off of our knowledge of the binomial distribution. So let's go back through that notation from the past. N stood for the number of trials, P stood for the probability of success on a single trial, Q stood for the probability of failure on a single trial, and recall that the probability of success plus the probability of failure on a single trial should add up to a total of 1, and also X represents the number of successes in N trials. So this is built off of the binomial distribution, this population proportion confidence interval development. We need to compute P hat. Well, if you recall on the previous slide, they surveyed 938 US adults, and they found that a total of 235 found most annoying. So what's X and what's N in this case? Well, N is the number of trials or the sample size. And that's precisely the 938 US adults that they surveyed. So the denominator here is 938. And X is the number of successes in N trials, and that's precisely the 235 that think that you know is the most annoying conversational statement. So X is 235 here. So if we take this and convert this to a decimal, this is approximately 0.25. So our point estimate is that roughly 25% of American adults believe that the conversational phrase you know is the most annoying of all. Now that we have our point estimate p hat, we can look into computing the margin of error E. As you know, the binomial distribution is a discrete probability distribution. We need a continuous probability distribution to compute our confidence interval here. Well, it turns out you can use a normal distribution to approximate the binomial distribution under certain conditions. And those conditions are precisely these. If n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5, then the normal distribution approximates the binomial distribution. So assuming these two things are satisfied, we can then compute the margin of error with this formula right here. Margin of error E is equal to z sub c times the square root of the quotient of p hat q hat divided by n. This z sub c is precisely the critical values that we discussed in our confidence interval introduction videos. So we need to know p hat, q hat, n, and z sub c to compute the margin of error. And just like p plus q has to equal 1 with the binomial distribution, with the approximations p hat and q hat, they also need to add together to equal 1. Provided these two conditions are satisfied, we will then compute this margin of error E, and we will add E to the p hat and subtract E from p hat to get our confidence interval. Let's go back to the original problem and actually complete it now. Let's read through once again. So in a survey of 938 US adults, 235 say the phrase you know is the most annoying conversational phrase. Construct the 99% confidence interval for the population proportion P of US adults who think the phrase you know is the most annoying conversational phrase. Interpret your results. So we already computed P hat, and we got that P hat is precisely 235 out of 938. It's the percentage of people in the sample who believe you know is the most annoying conversational phrase. And we found out that that's approximately 25%. Well, as we go to compute the margin of error, notice we need some other variables. Well, p hat and q hat, again, have to add to 1. So if p hat is 0.25, that means that q hat must be 0.75. We need n, which of course is just the denominator of the 938. That was our sample size. And we also need z sub c. Well, in this case, c is 99%. So c is equal to 0.99. We need the critical value associated with that c of 0.99. And if you recall, you have a table in your formula sheet such as this, where it actually gives you the critical value z sub c. So for a c value of 99%, so 99% confidence, z sub 0.99 is 2.575. Now we are ready to compute our margin of error E. Let's plug all this information into this formula. So E is equal to z sub 0.99 is 2.575 times the square root of p hat is 0.25 times q hat is 0.75 divided by the quantity 938. We need to approximate this margin of error, and as you put this into your calculator, you need to be sure that you put this entire radicand in parentheses, because you want to take the square root of this whole thing, not the square root of just this or just this. You want the square root of the entire quotient here. So make sure you put parentheses around these numbers here. When you do this, you get that E is approximately 0.036, or approximately 3.6%. So now that we've got p hat, which we computed previously, and we now just computed the margin of error E, we can create this interval by adding and subtracting E from p hat. So p hat plus E and p hat minus E are going to be the endpoints of our interval. And p hat is 0.25. We want to add to that 0.036, which gives you 0.286. And we also want to take p hat, which is 0.25, and subtract 0.036, which gives us 0.214. These are the endpoints of our interval estimate. So pictorially, what we got was p hat was the center of our interval, and we got that was 0.25. And then we just found the endpoints to be 0.214 or 0.214 and 0.286. So we are making an estimate, an interval estimate for the population proportion P, not P hat, right? We know P hat is in here because we built this thing around P hat. So we're making an estimate about the population proportion P. So ultimately our interval is P is between 0.214 and 0.286. This is our interval estimate with 99% confidence. Of course, that interval estimate there doesn't mention the confidence level. So we ultimately need to interpret our results. You should always plan to write a little sentence to end these problems. So how confident are we in this interval here? Well, we're 99% confident. So we are 99% confident that the interval from 0.214, of course, is 21.4%. And the reason I'm converting it to a percent is because we're talking about a percentage, not a mean. So we are 99% confident that the interval from 21.4% to 28.6% contains the actual population percentage, or population proportion, however you want to say it, the actual population percentage of US adults who find the conversational phrase you know. So US adults who find you know to be the most annoying phrase. I'm running out of room here. They find that to be the most annoying phrase. This is your final answer with the results interpreted. So again, let's quickly review the strategy before we move on. P hat, we want to compute that population proportion estimate first. Then we can compute the margin of error E using this formula, and we did that here. And then finally, we're going to add and subtract the margin of error from p hat. So we did p hat plus E, p hat minus E. This created the endpoints of our interval. So this is our interval. Again, we're making a statement about the population proportion P, not p hat. And we got to interpret that in words. So we are 99% confident that the interval from 21.4% to 28.6% contains the actual population percentage of US adults who find the conversational phrase you know to be the most annoying phrase. Uh-oh, we just committed a mathematical crime. Do you know why we can't do this computation yet? Technically, we've gone through all the computation, but we couldn't have done this computation for the margin of error. The reason is, as you can recall in the previous slide, in order for this to be true, this is your margin of error formula, you need to make sure that n p hat is greater than or equal to 5. And we also need n q hat to be greater than or equal to 5. So technically, what I'm doing, writing up in here in green, we should have done first, because if those two conditions aren't satisfied, then we wouldn't be able to do this computation, and we wouldn't be able to do this problem, period. So let's actually check that. Again, n was 938, and p hat is 0.25. 25% of 938 is well over 5. I don't even need to actually compute that. That's well over 5. And n times q hat was 75%. 75% of 938 is way over 5. So these things are both greater than or equal to 5. So technically, I should have done this first. And now, once I've verified these two things, then we can run through all these computations in this argument that we created.